Okay, if you see the characteristics of particles of matter, so already we have studied all the four characteristics of particles of matter. So that is the what is the first one, guys? That the particles of matter are very small. Is it yes or no? That is the first thing. So
Yes,
let us
sir.
discuss one activity. Particles of matter are very small. So let us discuss one experiment to prove this. The particles of matter is very small, and later second one is what they have spaces between them. Is it yes or no? So that is what is the spaces called as, Hari? Spaces between
Intermolecular
them,
force.
intermolecular spaces between them, and the particles is having spaces between them. And the third one is what they are constant moving. Understanding particles are moving. Particles are constantly moving. And the last one is what? What is the last
Particles of matter
one?
attract each other.
Particles of
Attract each
matter,
other.
they will attract each other. That is what it is. So particles attract each other. So these are the things, four characteristics of matter. Is it yes or no? So now if you notice it, one by one we'll study in detail. So now first all of you keep heading. The particles of matter are very small. So that is what we are going to study, the experiment. So what is the first experiment? To prove that particles of matter are very small. Very small. Now for this one we have been proved that starting experiments, the what is the first experiment, guys? We have studied different experiments. In that first experiment, everybody can tell me anything. Diffusion of solid in a liquid, that is what experiment. Dissolving a solid in a liquid, what is that experiment? Anybody try to remember and tell me. Dissolving a solid in a liquid, we have been done something. What we have been done, let me know. How many of you remember?
Potassium permanganate we solve, sir.
Dissolved potassium permanganate in water, so that the slowly the water color from transparent to it has been turned into how? It has been turned into purple color.
Purple.
So that is what. So potassium permanganate is present in purple color. So slowly when we dissolved potassium permanganate solid in a liquid, so that is what we studied. The color is completely changes into purple color. Is it yes or no, guys? Yes.
Yes, sir.
Yes, sir.
We are going to do now to prove that particles of matter are very small. Is it okay, everyone? Hey, please, what
Yes,
happened
sir.
to Tanishkar and Arun
Yes, sir.
Kailash? Bad boys. So now if you'll see, let us discuss. We have been done last Brownian motion and as well as mixing of two gases and etc. Now if you are going to take here, the very small size of particles of matter can be shown by performing the experiment, that is what potassium permanganate and as well as what, guys? Potassium permanganate, what is the formula? KMNO4,
KMN
and as well as you can take water. So if you dissolve this KMNO4 in water, the same experiment we are going to study for particles of matter are very small. Shall we discuss now, everyone? Now let us take,
Yes, sir.
everybody, so take 2 or 3 small crystals of potassium permanganate. How many crystals? 2 or 3 small crystals of potassium permanganate and dissolved in 100 ml of water. What do you mean by 100 ml, guys? How much it will come? 100 ml means just very small. Yes or no? So now take what we have to take first of all, everybody. We have to take the 2 or 1 or 2 small crystals of potassium permanganate and we have to dissolve in how much amount of water? 100
100
ml.
100 ml.
Clear? So 100 ml of water we have to take in one beaker and 2 or 3 crystals of water are ready. Potassium permanganate. What is the formula? KMNO4. Formula.
Oh,
We have to dissolve in water. That is what the first thing we have to do it. Now you can see if we dissolve the 2 or 3 crystals of KMNO4 in 100 ml of water, you can see the once the potassium permanganate is completely dissolved, then you can see we are getting a deep purple color. What is the color we are getting, guys? Deep purple color we are getting. Yes or no? So the potassium permanganate concentration is more or less more concentration. Yes or no, guys? Please respond.
Yes, sir.
Yes, sir. Now, all of you observe very carefully. The next what we have to do means, so now we will get a deep purple color when the solution of potassium permanganate in water. Now take 10 ml of deep purple solution of potassium permanganate from the first beaker and mix with 90 ml of water present in the second beaker. Clear? Now, so second beaker, how much amount of water, guys? Second beaker, how much amount of water? 90 ml of water. Now, from the first beaker, how much we have to take it? We have to take it 10 ml of water. Understand? 10 ml of water means what? Solution. Purima, everyone. Clear? Vartini, Gokul. So, from the first beaker, take 10 ml of solution and mix it with how much amount of water? 90 ml of water. Now, you can see. Have you seen the change in color? But still potassium permanganate is we are seeing. Still we are seeing the purple color. So that what is happening? It is still potassium permanganate transferred or not? Yes?
Transferred.
Transferred. Now again, next take beaker number 3. You can see. Again we have to take how much amount of water? 90 ml of water. Do you understanding everyone? 90 ml of water. And from this solution, how much amount of we have to take? 10 ml of solution. Okay, 10 ml of solution. If you mix it, now you can see change in color. We are keep on what we are doing, Harish. We are dilution. Understanding? Diluting. Okay, keep on adding the water. Understanding? So that process is called as diluting. Is it yes or no? Concentration on diluted acids. The similar way. So diluting. Now next beaker, beaker D. What we are going to do, Ragokul? Danishka, Arun Kailash.
Sir, take 10.
Again 90 ml of water we have to take it. Then what do we have to do, guys? Take
10 ml solution.
Yeah, 10 ml solution. So now you can see again 10 ml solution and 90 ml of water. Like this, you are keep on adding, you can keep on adding. See, even I have been done 1, 2, 3, 4, 5, 6 stages now totally. So here I am getting very light pink color. Do you understand? So if you do next also, keep on diluting, still the potassium permanganate is transferred. Yes or no, guys? Yes or no?
Yes,
So,
sir.
so from this you can say the color of solution will become still lighter and lighter. So when we keep on diluting potassium permanganate solution, like number of times, you can say 5 times, 6 times, 7 times, you can see with a very dilute solution of potassium permanganate water, but still the color what is there or not? Still the color is there or not? Yes or no? We are getting concentration is decreases. Potassium permanganate concentration is decreases. But you can see very light, very dilute potassium permanganate solution. But still the potassium permanganate is coming or not? Is it only water is coming? No. Yes or no? So even though you have been done 5, 6 times, still we are seeing the color of the solution. Means potassium permanganate is transferred. Yes or no, guys? So we are getting now, it has very light pink color. So you can see from this experiment, just 2 or 3 tiny crystals of potassium permanganate can impact color to a large volume of water. Yes or no, guys? Yes, please respond, everybody. See, one almost like 1, 2, 3, 4, 5, 6. So 600 ml of water, but still the color is transferred. But what is the crystals who have been taken? It's not 1 kg of potassium permanganate. How many? Just 2 or 3. Understand? Small crystals, but still the color of potassium permanganate is understanding to large volume of water. That is why from this potassium permanganate crystal itself must be made up of what? We can say it must be made up of millions of small particles which keep on spreading and imparting color to the more and more water. Is it yes or no, guys? Is it yes or no? So that is what. So since there are tiny crystals of potassium permanganate is suspended to made up of millions of particles. That is why we can say particles are what? The particles must be very, 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 very small. Yes or no? Ready? Have you understand or not?
Yes, sir.
That is
Understand, sir.
so. You see, just we are taking one or two or three crystals of KMnO4 means in the sense of what? It is made up of millions of tiny particles. Yes or no? Tiny particles. That is why it is, even though if you are mixed with keep on mixing with the water, even though the more amount of water is pouring, still the color is the color is appears, means still some particle is transferred. Yes or no, guys?
Yes,
Yes
sir.
or no? That is what. So, experiment, even sometimes they will ask in exam, prove that particles are extremely small in size, or else particles of matter are very, very small. Then you have to explain with this picture. Are you clear, everybody? So that is why I taught you. So what is the first experiment to verify the particles of matter are very, very small? Dissolved potassium permanganate. Understand? In 2 or 3 crystals of potassium permanganate, we have to dissolve in 100 ml. Later, 10 ml from that solution, and later we have to mix with what? 90 ml of water. Like that, keep on, we have to do 5-6 times. Still, we can see the color transformation. So, from that, we can conclude what? We can give the conclusion. Everyone. Arun Kailash, Danishka, what is the conclusion we can give? Particles are made up of very, very, very small. That is what we can say. Understanding millions of small particles which are keep on spreading and imparting color to the more and more of water. That is what we used to call it as. Is it okay, guys? Yes, please. That is the
Yes, sir.
first characteristics of what? Characteristics of matter. Okay. Particles. Yeah, very good. Now, what is the next second experiment? So first one came NO4 and water. What is the second experiment? Everyone, what is the heading? Second characteristic. The particles of matter have spaces between them. Please write. The particles of matter. The particles of matter have spaces between them. Shall we start?
Yes, sir.
Yes, sir.
Yeah. Now, observe very carefully. This is very simple experiment. You all people know. So, how many of you dissolved sugar in water till now? Can anybody tell me? Danishka, Gokul, have you dissolved sugar in water?
Yes, sir.
Yes. Now tell me. For example, I have given 100 ml of water. How much amount of water?
100 ml.
100 ml of water I have been given. Now I have been given 10 grams of sugar. Totally 100 ml of water. Okay. Now I have given how much amount of sugar, guys? 10 grams of sugar. Okay. Now I told you to dissolve this sugar in this water. Now you tell me, you all people dissolved. Now you tell me, is it the water, the sugar solution? Now it will turn into water. Water dissolved in sugar. Sugar is dissolved in water. It is called as sugar solution. Is it yes or no? Now, what is the total volume of sugar solution? Is it remains 100 ml or it is more than that? Reddy, Harish? Have you noticed it, for example? Yeah, you have taken a 1 glass of water. Now you dissolved sugar. Is it the water water amount is increasing or decreasing or same remains?
Increasing, sir.
Increasing. Will never increase, Reddy. Go and take 10 grams of sugar and dissolve in water. It will never increase the volume of water. Still, it will be remain same. You can see. Understand why? How it is possible? Something is added extra. So it has to be increased, correct? Why it is not adding? Anyone?
Sir, because liquids have moderate space between them, sir.
Very good. Understand? So that is why you are not seeing any increment in the level of water. Understanding? Any kind of change in level of water, because particles of liquid, they're having spaces. What is the spaces called as? Yesterday also I told you. Intermolecular spaces. Clear, everybody? So intermolecular spaces are present. So because of these intermolecular spaces, so when you pour the sugar, so the sugar will dissolve and will occupy the space between the particles. Purima, everyone. You understand, everyone? So that is
Yes,
why there is no increase in volume. Do you understand, Reddy? Gokul, Vartini. So that is what
Yes, sir.
the second experiment. The particles of matter have spaces between them. So let us discuss in detail and you can understand. So for this one, we have to take what, guys? We have to take experiment by using water and what? Water and
Sugar.
so now I will show you the pictures and I will explain you. You all people also can try in your home if you want. Still you can mark it, and if you are really interested, you can do it now itself also. It's not required much. Take one glass of water, tumbler you can take a transparent tumbler and take some amount of sugar and you try to do it. Now observe this picture ABC. Can you able to see the pictures ABC, everyone? Please respond. Arun Kailash.
Yes, sir.
Now I have been taken water.
Yes, sir.
Now, how much amount of water have been taken, guys? 100 ml of water. So, what is this mark? Red color indicate. What is this mark?
Water level.
Level mark. Clear? Now, 3 beakers you see, guys. Is there any change in water level? Is there any change in water
No,
level?
sir.
No. Clear?
Yes, sir.
That is what. See. So now if you notice it, I have been taken beaker 100 ml of water and how much amount of sugar?
50 gram.
50 grams of sugar. Now I dissolved it, sugar getting dissolved. So I'm stirring with a glass rod so that it will be fastly dissolved. Is it yes or no, guys? When we are stirring, it will be fastly dissolved. Okay. So now still are you seeing any change in water level? Danishkar?
No, sir.
Kailash? Now, no change in water level. Now, sugar is completely dissolved. So it is not called as water. So sugar is dissolved. That is called as what? We used to call it as
Sugar solution.
sugar
Sugar
solution.
solution.
Now, still you can see, is there any change in water level?
No, sir.
No, sir.
So that is what. So still the mark is remains same. So we can say the particles, between the particles we are having what? Spaces called as every particle. So between they are having some spaces. That spaces only we used to call it as what? Intermolecular spaces. Okay. So that is what we people can prove. Is it right or wrong, guys? Yes or no?
Yes, sir.
Yes, sir.
So when we look at the level of the sugar solution, it remains same. So from that we can say there is no change in volume on dissolving sugar in water. So it will tells us what? The spaces between the particles of water is present. Are you clear, everyone?
Yes, sir.
Yes, sir.
So that is what we can prove. It is spaces is present between the particles. That is what we can make it. So the particles in water are not tightly packed. So that is why we can see they're somewhat loose. So we can say they're having spaces between them. Is it okay, guys? Yes, please, all of you respond. That is what the second experiment. Now, next third experiment. What is the third experiment? The particles of matter are constantly moving. Yes or no? That is the third experiment. Let it be write it here only. So what is the third experiment? Please write it, all of you. The particles of matter. The particles of matter are constantly moving. Yes or no, guys?
Yes, sir.
Yeah. Shall we start?
Yes, sir.
Yes, sir.
Yes. Constantly, the particles of matter are constantly moving. Okay. Now, let us discuss what is that and how it will be happening. So, for this one, do you all know in our home, in front of God, we can keep something. Mainly like Vartini, Gokul, everyone, you all people know. We'll keep something which will give you good smell. What is that, guys? Puja time.
Incense,
Yes.
incense sticks.
Yeah, incense sticks. That is what in Tamil and Telugu same name. What is that?
Agarbatti electric.
Agarbatti. Understand? Incense sticks we can say. INCENSE. Okay. So incense INCENSE. Incense stick. We can say or we can say agarbatti. Is it agarbatti only Tamil also?
Yes, sir.
Yes, sir.
Yeah. AGR, Telugu also agarbatti. Okay. So let it be. So now if you'll see, this is the experiment we can do. The particles of matter are constantly moving. So what we will do means, you can see the best evidence for the particles of matter are constantly moving. That is what? Diffusion and Brownian motion, which we already studied. Yes or no, guys? Brownian motion. Yes or no? So that is already we discussed. What do you mean by Brownian motion? The random motion.
Random motion.
Understand? So if you'll drop the talcum powder or any kind of pollen grains, then pollen grains is continuously moving in the surface of water. Why? Because invisible water molecules is keep on moving so that the pollen grains also move. That is the experiment to prove that Brownian motion. We have been done. Yes or no, guys? Yes.
sir.
That is what. So now we will discuss. That is the experiment we can do again to describe the constant particles are moving constantly. But we can do understanding two more experiments which is involving diffusion in gases and as well as diffusion in liquids, which will shows that the particles of matter are constantly moving. Shall we start? Everyone?
Yes, sir.
Yes, sir.
That is
Yes, sir.
one. Now let us see first one. So first one is, so two experiment I'm saying now. First experiment. So when we light an incense stick or when we burn an incense stick in one corner of the room, you might be noticed it. Your mother is doing puja or you people are doing puja. So you might be burn the incense stick in one corner or every corner of the house. Only one
card.
house. Yes or no? So, but still, even though you are there, the smell we used to come or not. If it is, suppose you are in a bedroom, your mother is doing puja in God room, still the smell will come or not, guys, in our home.
Yes, sir.
Or no?
Yes, sir.
Understand? So the fragrance, we can say, the pleasant smell of this agarbatti spreads in the whole room very quickly. So that is what. So that observation we can make that the burning of incense stick produces gases. Yes or no, guys? It will produce smoke. Yes. Please,
Yes, sir.
ready? So that smoke or gases only we can say they're having very, very pleasant smell. So the particles of gases produced by incense stick, they will move rapidly in all the directions and they will mix with the moving particles of air in the room, and the room, it will reaches to the every part of the room very, very quickly. So that is what this is called as the gaseous particles from incense stick reach our nose with air, so that with a fragrance, with a smell. So that is what we can say which process it is. Diffusion by gases. Understand? Diffusion process by the gases. Yes or no, guys? High concentration to low concentration. Yes or
Yes,
no?
sir.
That is what.
Yes,
So
sir.
the particles of gases produced by the burning of incense stick and the particles of air, they were not moving actually. The fragrance of incense stick could not spread in the whole room very quickly. So if the basically, so but still how we are reaching it is because the observation that the fragments of burning incense stick spread in the entire room very quickly means the particles of matter are constantly moving. Is it yes or no, guys? If there is no movement, if there is no particles are moving, if there is no air is moving, is it possible to get the smell?
No, sir.
No. For example, your mother is preparing chicken curry in kitchen. You people will feel it. Is it yes or no? Before entering into the kitchen itself, you will feel it. Yes or no?
Yes, sir.
Yes,
How
sir.
you will feel? How you will feel, guys? I want to know the answer.
The smell, sir.
Because
The smell of-
the smell will spread. How it will be spread? It will spread through the air only. Understanding? So that process is called as diffusion. Understand? So same way this agarbatti, the gases will produce by burning of incense stick. They will be high concentration, and air, no agarbatti things is present, so low concentration, and both will keep on moving very fastly in the room. That is what. Understanding? So the fragrance smell or pleasant smell will come from the agarbattis, even though if it is burnt in one corner of the room. Do you understand, everyone? Because of
Yes, sir.
constantly moving of whom? The particles. Understanding? Gases and as well as
Air
air.
particles.
Yeah, gases and as well as air, both particles are moving constantly. So that is why it is happening. Is it okay, everybody? Yes or no? So that is what?
Yes, sir.
Diffusion of gases, we can say. Next one, diffusion of copper sulfate into water. That is the second experiment. What is the second experiment? First one is burning of incense stick, and the second one is diffusion of copper sulfate in water. Shall we start? Diffusion of copper sulfate in water. Okay. Now copper sulfate formula I'm saying now itself, class 9th itself, some formulas at least you learn. Copper sulfate is CuSO4. Is it okay, guys? Everyone? Copper sulfate. Danishkar, Vartini, Gokul, any doubt you ask me. Now, so this is the second experiment to prove that what? Again, the particles of matter are constantly moving. Is it okay, guys? Yes?
Yes, sir.
Now, so we'll describe this diffusion of copper sulfate into water so that we can understand very easily. So diffusion means we know that. What do you mean by diffusion, guys? Dissolving of high concentration to high concentration to carry out into the low concentration. That is what we used to call as diffusion. Okay. Now, let us take, as we know, what is the copper sulfate color? Anybody can tell me? Harish, Danishka, Gokul. Everyone, so it is blue in color. What is the color of the copper sulfate? It is a
Blue.
Blue.
color. Okay. So now, if you dissolve this blue color, when a few crystals of copper sulfate are placed at the bottom of the beaker, which is containing water, then the whole water, understanding the whole beaker turns into which color? Slowly.
Blue color.
It will be
Blue
turned
color.
blue color. So you have been taken some kind of a container, and if you have been added a blue color crystals, clear everyone? So I have been taken
Yes,
copper sulfate crystals here. Now if I'll pour the water, so what will happen? So if I'll pour the water, slowly these copper sulfate crystals will dissolve and they'll spread throughout the water, and finally it will turns into what? Copper sulfate solution. Is it yes or no? So that is what you have to.
Yes, sir.
It will turns into copper sulfate solution. So here, if you'll notice it here, so the whole water in the whole beaker will turns into blue color. How it is happening? Because the basis of motion of copper sulfate particles and water particles as well as. Understand? So the crystals of copper sulfate dissolved in a little of water around them. Understanding? They'll form fine particles of copper sulfate solution. Okay. Now the particles of copper sulfate in solution, they are in motion. The particles of clear water are also keep on moving. So that what is happening? Slowly, due to the motion of the particles only, the blue color sulfate particles in solution, they will move upwards in the beaker, and the color of the water particles will also, what will happen? Move downwards and they will mix each other. So that what is happening? That process is only we used to call it as what? Diffusion.
Diffusion.
Understand? So the diffusion of copper sulfate particles and water, the particles into each other goes on until the whole water turns into what? Whole water turns into
Blue color.
Understand? So the blue color will be coming up and this water particles is going down. So slowly keep on exchanging this. That exchanging is only we used to call it as diffusion process. So until it will completely equally turns into blue color, it is keep on exchanging these particles. Is it okay, guys? The blue color copper sulfate particles, they will move upwards in the beaker, and the colorless water particles, they will move what, guys? They will move downwards and they'll mix each other. So that is what we can say diffusion process. Okay. So now the spreading of blue color of copper sulfate crystal in water, understanding is due to the movement of what? Due to the movement of both the particles. What is the both the particles? Anybody?
The water particles and
Particles? Yeah.
copper sulfate.
Copper particles, and as well as another one is what? Another one is water molecules. Okay. So this movement of copper particles and water molecules, that is what is done by diffusion. So that diffusion process is only, what is the process name called as this one? What is the name of this process? Yes?
Diffusion.
Diffusion. Okay. Now why we are studying these two experiments? To prove that particles of matter are constantly moving. Is it yes or no? So that is what it is.
Sir.
So this is what about the two experiments. So kindly all of you learn, and it's very, very important. Okay. So this is what it is. You can see if we'll carry out this experiment, for example, all of you tell me, I have been taken, now same experiment you have been taken. For example, I have given one glass of water and another glass of water. This is hot water and this is normal water. Now I have given both 50 ml of 10 grams of sugar. Now you tell me, and here also 10 grams of sugar. In which beaker it will be fastly dissolved? Everybody?
In hot water.
Hot water. Because they are understanding the rate of water turns, understanding dissolution of sugar, and as well if you take copper sulphate, then it will turns into blue at faster rate, because on heating the particles of water and the copper sulphate, they will get the more energy. That energy only what I said, moving energy,
Kinetic energy.
energy due to the motion which is acquired by the body, which is called as kinetic energy. Is it okay? So because with this kinetic energy only, the particles, they will move faster movement and they'll mix each other more and more quickly. Is it okay, guys? Everyone?
Yes, sir.
Yes, that is what you have to remember. So please all of you remember. So that is why, so this 10 grams of sugar, same way can take the dissolving in normal and as well as hot water. Hot water will releases more energy. Understanding? That is why you can see it will be fastly dissolved in the hot water until it turns into solution. So this is the third characteristics of particles of matter. That is what? What is the third characteristic, guys?
Particles of matter are
Particles
continuously.
of matter are constantly moving. So two experiment, or else you can write kitchen experiment also. Your mother is cooking in the kitchen. You will get the smell till bedroom. How it will be possible, guys? Because, because of what ready? Because of
Air molecules. Sir.
air, and as well as what? The smell, the fragrance smell, which is the
Chicken smells. Sir.
chicken smell, the masala smell, or whatever the recipe we are using, that is the smell. So that smell will be start diffusing with the air, so that air particles are constantly moving, so that finally it will reach us to our bedroom also. There also we can hear, we can feel the smell of the kitchen, whatever it is prepared. That is what it is happening. So that process is only diffusion only. So this is what three characteristics of matter. Next, what is the fourth characteristics of matter? The particles of matter attract
Each other.
each other. That is what. So let us discuss the particles of matter. Particles of matter attract each other. So as I told you yesterday, each and every particle, they are having some force. What is that force? Yes, please. What is that force, guys? Attract each other. So here keep some gap. What is the force we used to call it as? Intermolecular force. You remember, everyone? Yesterday only I told you intermolecular force. Yes or no? Now, there are some forces of attraction between the particles of matter which will bind them together. So if you'll take anything, suppose I have been taken one kind of my phone, do you understand? My water bottle, how they are having a particular shape or whatever it is, if you take water, understand? So why the particles are not keep on moving away from each other? Why, guys? Water also, phone also, water, everything. Because of why? Because of some forces, invisible forces are holding them together. That invisible forces only we used to call as what? What we used to call, guys? Yeah, intermolecular forces. Clear? So the force of attraction between the particles is, you can take here very carefully. So that is what is always present. Either it is maybe a solid or maybe liquid or it may be a gas, doesn't matter. So maybe force amount is varies, but the same force, understanding. So the same amount of force exerting by the bodies may different, but it will be the same thing. That is what you have to remember. Okay. So it will never allow to escape from the things. That is what, if not every particle is to move. So that is what it is happening. So because of some invisible force only, the both you can see it is what is happening. The particles are getting closer or they are not moving far each other because of this force of attraction between the any two particles in the universe. Clear? So that forces only we used to say intermolecular forces. So if these forces are more high, then we can say what is that forces? Strong, so that it is called as solids. If it is less, little bit less, liquids. If it is extremely low, gases, we can say, because gases does not have any kind of like extremely low pressure, it will be there, so that they can easily rush into the anything, you can say the gases